Sir, whether my voice is audible?
Yes, audible.
Yes, ma'am.
Yes, ma'am.
Okay, okay. Good evening, one and all. Now we will start our next session on AI and ML in charging infrastructure and energy management by esteemed expert speaker Dr. V. Jayashreee. So before we proceed with the session, we will have a brief introduction of our expert speaker. Dr. V. Jayashreee is an eminent academician, researcher, and distinguished expert in the fields of electrical and electronics engineering. She is currently serving as Professor Electrical Engineering and is a PhD recognized guide at Decades Textile and Engineering Institute, Ichalkaranji, Maharashtra. With an illustrious academic and professional career spanning over 38 years, Dr. Jayashreee has made outstanding contribution to teaching, research, curriculum development, and academic leadership. Dr. Jayashreee is a National Merit Scholarship awardee, stood second rank at Karnataka University, completed her bachelor's degree in electrical engineering, and earned her PhD in electronics engineering from Shivaji University, Kolhapur. She has served in reputed institutions including BVP College Hubballi and DKT TEI, where she has also held key leadership roles such as Head of Department Electrical Engineering and Electronics and Telecommunication and PG Coordinator for MTech Electronics. She has an impressive research profile with more than 38 journal publications and 27 conference papers, indexed in Scopus, Web of Science, Elsewhere, and Google Scholar. Her research interests include artificial intelligence, machine learning, deep learning, computer vision, VLSI design, automation, and electrical application in EVs. She has authored 4 technical books, guided 55 plus UG projects, 21 PG dissertation, and is currently supervising 6 PhD scholars. Dr. Jayashreee has delivered 20 plus expert lecture in FDPs and academic program and has been an invited speaker at international conferences in Denmark, Malaysia, Finland, Spain, Japan, and UK. She has also served as a reviewer and editorial board member for reputed international journals and IEEE conferences. A recipient of several prestigious honors, including Best Teacher Award, Educational Excellence Award, IAI Best Technical and Societal Service Award, and Lifetime Achievement Award. Dr. Jayashreee is a senior member of IEEE and life member of IST. Her passion for value-based, student-centric education and commitment to academic excellence make her an ideal resource person for FDPs, particularly in emerging domains like AI/ML-enabled electrical and EV applications. So with this brief introduction, I request Madam to start her session. Thank you.
Thank you, madam, for your very nice information on me. First of all, I would like to thank the organizers, especially HOD, Dr. R.N. Patil, sir, for having given me the opportunity to be the participant in this webinar, which is online for the FTP, and also giving me an opportunity for serving as a resource person. Thank you for giving me such a good place for sharing my knowledge that I have gained throughout my service in AI and ML, which I have gained recently after my PhD. And actually, the name of the topic that is being displayed here is AI ML charging infrastructure for electric vehicles. But I'll slightly deviate from this and make you comfortable, first of all, in order to understand the concepts of AI ML and the usage of all these AI MLs in practical implementation, in order to bridge the gap between what we have learned and what we need to practice in order to train not only ourselves, but also our students, and also guide for our and also do some research work. And if at all some guides are there, they can go ahead with the guiding part. If at all they don't have knowledge, or they may have some amount of knowledge, or they may be well versed, it doesn't matter, but we need to revise many things at different times of our service. So I think I have chosen a topic that is AI ML applications in electric vehicles for predicting the faults that might occur in some components of the electric vehicle and also on energy forecasting. So for these, we require some basic machine learning algorithms. As we have gone through the various sessions in the previous days, we have learned that the most of the machine learning algorithms that are used may be like supervised learning algorithms consisting of logistic regression, decision tree, random forest, boost algorithms
Madam, can
like
you share your
XGBoost.
slides?
Yes,
Slides
sir,
are
I'll
not
do that.
shared.
I'm just giving the introduction. Okay, sir. And also on some of the deep learning algorithms where we are more focusing on predictions because they can work better compared to all other algorithms. So with this small note, I'll be now sharing my slides for starting my session. Thank you. Can you see my slide?
Yes, ma'am.
Yes, thank you. So this is my topic, that is ML and DL-based intelligent prediction for electric applications in EVs with little bit of hands-on. So in this, I'll be covering the scenario of AI, the overview of ML to move towards ANN. So in this, in ML, we'll be covering some supervised learning, where we'll be looking at some sub-basic algorithms, which I have displayed there. Unsupervised algorithms, where we'll be focusing on some k-means clustering, support vector machines, and then artificial neural networks, wherein we'll move towards CNN, RNN, and deep learning and LSTM. So in artificial neural network, we may have to learn something regarding the various terminologies and their usage. And then we'll move to the electric motors fundamentals, where we'll be studying little bit review on the types of motors and the types of motors needed for our electric vehicles and how to monitor the electric motors. That is for its health diagnosis. Then we'll be looking for the platforms for implementing the motor fault predictions and also for energy forecasting, which is useful for deciding when to charge and when to discharge the batteries. Then we can look at deployment of AI model in a processor called Raspberry Pi 4B processor, and we'll be concluding with summary. So we know that we have got the AI ML DL structure that is shown as in this figure. So first of all, artificial intelligence is the base for everything, which is mimicking the intelligence of living beings. And then it is making the machines to think. And briefly, if you look at machine learning, it is learning from the past experiences, and it helps us providing the statistical tools which it uses for learning the past experiences. So here in this, we have got different kinds of learning like supervised, unsupervised, and semi-supervised learning. The next one is the more complex model, which is deep learning, which is subset of the machine learning. And machine learning is subset of artificial intelligence. And in deep learning, we have got the learning architectures which are based on type of data like ANN, CNN, and RNN, which depend on numbers, images, and time series data respectively. Encompassing all this artificial intelligence, machine learning, and deep learning is the data science, which gives us some mathematical tools encompassing the linear algebra, statistics, probability, calculus, etc. Then if you look at this figure, here I have got the artificial intelligence as the core for development of all other algorithms. So you can see here the machine learning and its associated algorithms which have been developed, and then the neural network that is associated with this artificial intelligence, and the successors of this neural networks consisting of deep learning, convolution neural network, recurrent, and stochastics. And this recurrent and convolution neural networks, they have combined to form what is known as LSTM. Now, if you look at the progress of the neural network, which has come through the development of machine learning, its performance is studied over the period of time, where classification error is compared with that of the human error. If we see that after 2015, the error that is possible by the neural networks has outperformed with respect to the human error. So because of this, the progress have been very rapid later on in terms of applications in classification, prediction, decision making, object detection, monitoring of machines and anomaly detection, forecasting, and recommender systems. Now let us look at machine learning algorithms, where we have got the three basic classes like supervised, unsupervised, and reinforcement learning. Where in supervised, we have got two types of algorithms, classification and regression. Under that classification, we have got different types of further algorithms like new Bayes, decision tree, support vector machines, random forest, etc. Likewise, regression also has linear regression, neural network, and support vector, and decision tree regression, and some new regressions like lasso regression. Then clustering we have, which is coming under unsupervised learning, consists of k-means clustering, DB scan, agglomerative hierarchical clustering, and Gaussian mixture clustering. Then last one is under the main class of reinforcement learning, we have decision-making concept, where there are sub-algorithms like Q learning, R learning, and TD learning. So if you look at supervised machine learning, we have two classes under that, classification and regression, where classification algorithm, it goes for predicting the discrete class labels, whereas regression algorithm goes for predicting the continuous quantity. So if you look at classification example, if I have cat and dog, if I want to classify them, then I need to look for their features and then plot the features on a graph and look at what are the separation boundaries which separate the features in making the prediction of class of cats and dogs. So in case of, whereas in the case of regression, we have got continuous quantity to be predicted, where a simple example can be the house price with its different features like size of the house and the amenities of the house, where we can go for applying regression. So we have seen that AI can be applied for EVs. In EVs, we have got a main driving train as a motor, and this motor needs to be made as efficient as possible with respect to the power consumption, wherein it requires the controller and optimization of the inverter, where it is driving the electric motor. So in electric motor, we need to see the health of that motor with the help of prediction of faults and optimization of energy. And also, first thing, we will be looking at optimal torque speed prediction. But all are data driven methods. So they can be classified for prediction under artificial intelligence and deep learning, wherein you can go for having the study of artificial neural networks, support vector machines, LSTM, CNs, and the machine learning algorithms, which I'll be a little bit giving fundamentals. So the implementation of any artificial intelligence algorithm, basic is ANN, where we need to have the acquisition of the raw data. For example, it can be a current signal or a voltage signal or a temperature signal, or it can be a vibration signal. Then it needs to be pre-processed with respect to the data, where we go for noise reduction and some kind of corrections. And also we have to go for extracting the important features of this pre-processed data in order to find out the meaningful information so as to make the model to do the prediction optimally. So last, if we want to classify the kind of faults, then in that we need a system component called as classifier, where we go for assigning some given input patterns to several predefined classes. So let us look at the comparison of the ANN and its successors. So ANN is the basic algorithm that is developed in machine learning, which is forming a fundamental algorithm for the successors like CNN, RNN, and also DL, and also next LSTM. So if you look at ANN, it requires features as inputs, but it works when the data is structured. It is good for classification problems. If you look from the point of view of application of the electrical vehicles, you can say you can find the motor fault types, and also you can do the classification. Not only that, you can go for finding the types of faults that are occurring in EVs because of a number of components. There can be a number of faults that may occur in different parts at different times. So you can fuse the various sensors and look for from where the fault has occurred, and also what is the type of fault. Now, another thing is that you can go for predicting the energy for its tariff. Okay. And then next one is CNN. CNN does not require the block which needs to have the feature extraction, but it directly takes the data and goes for extraction of the features. And it also works good when the data is structured. And it can be used for image classification, segmentation, and object detection. Then you may you may think where the image classification concept is applicable to the electrical engineering EVs. So it can be used for motor fault classification using FFT obtained from, that is fast Fourier transformed image obtained from the current signals. Then next one is the recurrent neural networks, which are good for sequential data, and especially the data should be in order. And for example, the current signal, if you take in our electrical engineering, it has got the different states like transient state and the steady state. That means accordingly it has got two parts. And we always expect that the steady state has to occur after the transient period only. That means the order is needed here. So it is also sequential data where the order matters here. Then you can go for using this for time series forecasting, like energy forecasting. The last one is deep learning, which uses multiple layers progressively, but it helps for extracting the higher level features, which is very unique to the unique when compared to all other successors like ANN, CNN, and RNN. So it is very powerful algorithm. Then architecture of a basic ANN consists of input layer, hidden layer, and the output layer. Then deep learning consists of the modification of this, where instead of only one single hidden layer, the number of hidden layers for deep learning algorithms, they are more than one. So in order to make the learning of various features at different hidden layers, in order to make the extraction of features in an optimized manner, in order to decide the classification results appropriately. Then convolution neural network, which is also derived, which is one of the deep learning model, where you can see here the image which is in the form of EV, that is car, is being given. But you can also go for giving the heat maps of the machines and current signature FFT images as input to this convolution neural networks, where it consists of number of convolution layers. Each convolution layer is made up of convolution consisting of different number of filters. and size of filters and ReLU layer and then pooling layer. And such three layers, they form one convolution layer, and such set of convolution layers can be repeated based on the application. And there can be the last layer, that is classification layer, where we go for flattening of the downsampled data in order to go for assigning the probabilities and then finding the classes of the image, where we go for in electrical engineering, maybe assigning different kinds of faults for the output. The downsampling is carried out by pooling layer, and rectified linear unit, it goes for finding the information from the weights, and then it goes for carrying forward the activated features from the previous layers to the next layer. And also, it is important that in case of CNNs, the hidden layer of a particular hidden layer of a particular number or a particular say there are 1, 2, 3 hidden layers. For example, hidden layer 1, all neurons, they get the weights which are same. Because of this feature, it is helpful for the CNN to identify features which are tolerant to the translations feature, object translation feature. The last layer is the classification layer, where the fully connected layer is developing output layer consisting of k dimensions, where k refers to the number of classes based on the calculation of probabilities for each class. Now, why deep learning has been used? If you look at the definition, you look at the reason, let us see at the graph consisting of performance of the deep learning algorithm with respect to other algorithms with respect to the amount of data. So if you see the red line, it is having its performance, which is almost remaining flat for an increased amount of data. Whereas if you see the performance of the deep learning, its learning performance has improved with the increase in the number of data or amount of data. Because of this, deep learning has become very much useful for various applications in various fields, and also with respect to electric vehicles. Now, next one is RNN. It operates on the sequence of data, and it is also used on in LSTM, that is long short time memories. But in case of RNN, it goes for using a hidden loop, a hidden memory, and there is a loop. And this hidden memory, it goes for storing the information of the previous or the past data, and it also helps for extracting the feature that are present at its from its input. And it can be used for forecasting the model. Which one is used for forecasting the model is that it is LSTM. It is not the simple RNN, because LSTM becomes more effective for forecasting when it is associated with the convolution neural networks, which is capable of finding the features and which can be inputted to further the LSTM. Now, in this slide, we can see that there are 3 channels of the inputs that are being given, out of which the blue color indicates the inputs which is available for certain period of time for all the 3 channels, but the remaining are nothing but the predicted ones based on the previous time step input by the LSTM. Okay, so the LSTM neural network helps to forecast subsequent values of time series or sequence using previous time steps as input. Now, this LSTM can also be used for different tasks, not only for classification, as well as it can be used for finding out the continuous varying quantities, like regression algorithm. It can be used. It also can be used in video classification, where you can see that here there is a convolution layer that is incorporated, which is giving the features for LSTM layer, which is present just before the output layer. Then this is the fundamental block schematic for electric motors. We all know it, but in this, we need to take the feedback from the vehicle body, which is controlled by the motor, and a motor is controlled by the motor controller, and the motor controller gets the control signals from the input signal, which is compared with the feedback signal. Now, if you look at the tree of this electric motor, we are all well conversant with all these kinds of motors, but the kind of motors which are used, they are more focused on asynchronous motors like induction motors and brushless motors, which are BLDC motors, and permanent magnet brushless motors, switch reluctance motors. Now, when we are selecting the motor, we will be looking for efficiency, instant power, high torque, and high power density, low cost, and acceleration, and also robustness. Based on this, if you find the scores for all this for different categories of motors, as seen in this block of the table, we can see that the induction motor and the BLDC motor, they obtain a score of 35. That means it is highest. Not only that, even PM, permanent magnet synchronous motor, it takes score almost equal to that of the induction motor and BLDC motor. But in motors, we have got the requirement of motors for electric vehicles at various places. I will not explain all of them, but there is an important component, that is a powertrain motor, where it requires based on the capacity of the vehicle. Like we will be using BLDC or PMSM or induction motors. Then if you see Tesla's model, they have gone for using the induction motors because it is capable of producing, as we know, good torque at all RPMs. So this is again telling what are the motors that are used in electric vehicles. But apart from that, this curve is important, where it is telling us the black curve, the total power, and the remainings are the powers required for different aspects like aerodynamics, train, then for required for the tires, etc. Now, this also we know the size of the motor is going to be dependent on, the size decides the amount of power of the motor that can be produced. The next thing is that we are interested in finding the life of the electric machine, that is electric motor, where finding the remaining life of the machine also requires finding the type of fault. And this shows the curve which is plotted against condition indicators versus the remaining useful life. And this arrow line that is shown by dark bar, it is nothing but the remaining useful life between the current condition and the failure condition. So what are the current condition indicators that we'll see? They are the important meaningful features. Now, if you look at the maintenance of a machine, we'll be looking at three types of maintenances. One is reactive, another one is predictive, another one is proactive. But in that, I'll be looking at whether my machine is operating normally, or whether my machine is behaving abnormally, or do I need to look for a machine, for another machine, because my current machine is not working. So for all this, I need to find out the answer through the concepts like anomaly detection, fault detection, that is fault diagnostics, and remaining useful life, wherein I'll be requiring to take the sensor data and apply on these the predictive algorithms and then go for actual prediction. Then if you look at this predictive maintenance workflow, you can have two types of data. One is the actual data, another one is the generated data. And you need to importantly pre-process the data, where you need to identify the important features through feature engineering. That is by taking raw data and converting it into meaningful input variables to improve the performance of the models which are going for predicting. And then you need to train the model and deploy the model. So we said that feature engineering is important, which requires pre-processing of the data, where it has 4 different types of tasks to be performed, like data cleaning, data transmission, transformation, data integration, and data reduction. In data cleaning, simply if there are duplicates, you have to remove them. And if there are missing values, you have to replace them. Then under data transformation, we need to convert the data between minimum and maximum into a normalized value, where we have to go for scaling. Also, we need to encode them with the help of encoding numbers like one-hot encoding, or classes like 0, 1, 2, 3, etc., based on the number of classes. Then data integration needs to be carried out by looking at the concepts like joining and merging. So these things I have done in actually while pre-processing my data that is taken from the motor, current signals and vibration signals. Then data reduction is also required sometimes, wherein we'll be using 2 other concepts like sampling and reduction of a dimension of the data using dimensional reduction concepts. So if you look for the workflow, we have data preparation, then model development using the different platforms like Colab, where we can go for using the scikit-learn, the Keros, the TensorFlow, and also after development of the model, we need to go for implementation using the STM electronics processor, or Raspberry Pi 4B, which is easily available. So this is one of the concept of how we can go for monitoring of an industrial motor, where we can take mechanical vibration and also the other inputs like speed, acceleration, torque, and displacement. The motor will have the different kinds of signal acquisition system along with this as another component, and this needs to be acquired either directly through wired or wireless communication with the help of IoT sensors. And you need to signal condition these signals which are obtained using the signal conditioning circuit, where you may have to go for amplifying, filtering, and pre-processing. After it is pre-processed, we need to go for building a model and then training a model using this pre-processed data. And then you need to find the faults and then go for classifying the faults. Then you can go for using the various advanced analytics in machine learning, where we can go for fault diagnosis, and also we can incorporate the user interface, can be a dashboard for visualization of the state of the machine, and also the kind of alerts that are coming, and also the maintenance that is to be carried out. So one example I'll take here, where the signal is present here on the top side, where we have taken the features from this signal, and the features are MFCC. This is a Mel frequency coefficients, and there is an image of this. Then we have developed a model that is a light model in TensorFlow, and we go for finding the probability of action to be taken or not taken. Suppose the first set of time series data has produced a probability of 0.02. It says that there is no need of action because the threshold for action is at least should be greater than or equal to 0.5. Now, if you go for the next window of data, again, it is not more than 0.05. So 0.5. So the probability says that there is no need of action. But if the third window of data is taken, it might give you the probability more than 0.5, for example, 0.89, where the input given to the model consists of the heat maps, and it is not a heat map, it is FFT image map, which are shown in this black color with the red spots in between, based on the type of faults like a broken bar, broken rotor bar, and race bearing fault, and rare bearing fault, it is bearing ball fault. Okay. And since there is a probability obtained greater than 0.5, it says that there should be some action. Now, we know that there are different kinds of faults, majorly mechanical and electrical faults. We all know this. We have stator winding and rotor winding faults. And also, we need to look for the health monitoring purpose, where it is helpful for preventing the failures and downtime. Also, it is helpful for quick decision making and carrying out the immediate response. Data collection is a challenge. It may be wireless or wired. But when you have the data, there must be a visualization which gives us the alerts and notification. And we need the EV prototypes to incorporate health monitoring for the motors with the help of feedback loops for optimizing efficiency and preventing the damage. That in order to look at the machine health monitoring, we have different kinds of techniques like analyzing the vibration, analyzing the current signatures, monitoring the temperature and analyzing it. And also you can go for taking the acoustic signals which are generated. Then to do or apply these techniques, we need to have some signal processing for speech extraction, where we can look for analysis in time domain, analysis in frequency domain, using the features obtained from FFTs, or that is fast Fourier transform, and then it can be also wavelet transform. You can also go for having the clubbing of both the kinds of processes, that is through time frequency analysis. And also there can be different feature extraction techniques. So if you look at on the top side, the diagnosis methods for the fault, we can have model-based methods and signal processing methods, and machine learning and deep learning approaches, which are data-driven. And also there can be hybrid method. So if you go for implementation of predictive maintenance for motors, we need to have data collection, then selection of a platform for programming, then model building is required. Then we need, in model building, splitting of data into train and test data, and training a model, testing using a model developed, and then we need to develop this model for different kinds of algorithms and compare the performance and choose the best one. Now I have selected a data from a site called as Zenodo, and it includes different types of data, the raw data, the process time data, and the frequency domain data. And it consists of the objective having the diagnostic procedure for which is sensitive to phenomena occurring during startup process. So when it is to be looked for data collection, they have taken 4 identical induction motors, out of which 1 is healthy and 3 are having rotor faults. Maybe 1 is having single rotor broken, and the other 2 are having, 1 is with damaged ring, another one is 2 broken rotor bars. Now this is essential to find out the startup current measured for all the kinds, all 4 models, in order to look for the variations that are occurring during startup. And important thing is that the sampling was done at a frequency greater than 1000 Hz, that is the 1150 Hz. Now I will show the website from where the data is being taken. I said it is Zenodo. So this is this. Are you able to see this website? Anybody can endorse this?
Yes, ma'am.
Okay. So from this, I have taken the data. And there are other data websites available. Now, more importantly, we are towards the IEEE website. And if you look at this is the website for IEEE data port. And it consists of data sets for different categories. So you can see here, agriculture, astronomy, biomedical, health sciences, communication, computational intelligence, COVID, education, geoscience, IEEE, many are there. You can go for searching that using the search search on electric vehicles. And if you search that, you will get many of them. So first one, if you see here, electric vehicles, smart cars, MATLAB simulation for MATLAB-based, model-based design for hybrid electric motors. And likewise, you will get 1 year recording of electric vehicle charging fleet. So yesterday, Suraj sir was telling, and he was talking about battery management system. So you can look for such kind of data for this. And likewise, you have got many other data related with electric vehicles. So you can go through it. This is these are some examples that I have shown. Then Kaggle is also there, where you can go for looking for data sets. So induction motor fault data set. So you can see this. This is the Kaggle website. So likewise, some other websites are also there. So you can search and then find out. But more authentic, you can see from IEEE as well as Kaggle. It doesn't matter. And even Jonado is providing many from European countries. So let us go ahead with this further. So pre-processing of data set is very important, where it is having a raw signal, filtered signal, and then frequency domain signal and normalization. That is pre-processing part. So let us look at some of the signals. So these are the raw signals which are healthy. And the second one that is shown is a filtered signal. And the first row, it shows the starting currents which are taken for different periods of time, for different loads. Similarly, this is showing the healthy filtered signals for different intervals of time with different currents. Okay. Then this is for one damaged rod. And these are the filtered signals for one damaged rod. Then the next one is with the damaged ring, we have the filtered signals, wherein you can see the different periods of times are being considered. So you can see here 4.5, here you can see 3, here you can see 2.2, something like here you can see 1, 0 to 1, etc. Likewise for two damaged rods. Now FFT is applied on this, and it is sampled with different sampling at 0.2 hertz. Then healthy damaged rod FFT signal, two damaged rod FFT signal, and damaged ring FFT signal. Likewise, when it is taken for 0.4 hertz, the 4 different normalized FFT signals are shown here. Again, recall this, that deep learning is the subset of machine learning. Machine learning is for subset of artificial intelligence. Now, let us first start with the machine learning algorithm, where we will be studying supervised learning algorithm consisting of linear regression, decision tree, random forest, boosting algorithms like ADA and gradient boost, then classification algorithms like logistic, SVM and KNN, unsupervised, K-means and collaborative learning. So let us look for the first one, where if I have some set of data, what I'll do, I want to find out two classes. In that case, what I'll do, I'll fit a straight line. Straight line equation is shown with the kx plus b, where it can have continuous variables related with house price, height, and income, or it can have categorical variable like colors, species, and marital status. Now in this, I can have the training linear regression model consisting of an equation of this kind, where you can see k being replaced by a random coefficient, which is same as weight, and the b being replaced by a value 0.005, which is nothing but the bias term. So we'll be now learning the different terminologies that are required to be used for developing our model. So in this next slide, what we see is x and y are the two variables where we'll be looking for prediction and prediction that is done, he has given me a values like shown here. Then I calculate the squared error by taking the difference between the predicted and the actual, that is 3 minus 0.007. Likewise others. Then I'll go for calculating the mean of the squared errors. Then say it is 51.51. Then we go for finding the error for different k values which are randomized. And then you may see the graph of this kind where the error is reaching some minimum value for the given fit. Then it needs to be obtained with the help of optimization, that is, for example, gradient descent algorithm. You can just skip this. We can use this concept for classifying the mails into spam and no spam, that is useful mail. So if you want to go further, let us take an example, that is having a company where there are people with different ages and different salaries. I want to apply linear regression where I have got X and Y, where relationship between this X and Y is to be established. That one is independent variable, another one is dependent variable. Then I need to plot this data and try to fit the line where this line can be of anywhere, like it can have a line that is shown by this one first line that I am showing with the help of my cursor, or it can be of this kind. But after this, what I need to do, I need to go for finding the best fit by finding the error between the actual and the predicted. That is by minimizing the distance from the points that are found out with respect to the actual one as shown here. So these are nothing but the errors symbolized in the form of E1, E2 and E3, and then take the square of these errors and sum them and average them. Then let me use it for finding the salary of a person at 50 age. What I do, I go for converting this equation into the salary given by the M and X being replaced by age and C being replaced by some bias value. So if I take it as 0.2, then I can go for calculating with a B value of 20,000 and say that the salary of that person is so and so. But in linear regression, I need to go for converting this linear fit equation into a hypothesis function, which consists of the slope that is defined by theta 1 and the bias term that is defined by theta naught. These are called as the parameters which are to be learned by the machine learning algorithm. Now here, our intuition is to choose the learning parameters. What is the intuition of theta choosing these parameters? Let us see it through some examples. If my value of theta 1 is 0 and theta naught is 2, then I'll get the fit like this, that is shown in this first figure. Then for theta 1, 2 and theta naught 0, I'll get a fit that is shown in figure number 2. And for the third set, that is theta 0, theta 1 having one value, for its parameters, it will give a straight line with an intercept. Then let us look at linear regression, where hypothesis function for the house price based on the area of the house can be fitted in a hypothesis function of the kind where we go for having a prediction equation given by y hat is equal to h theta x, that is given by the combination of the two parameters like theta naught plus theta 1 x. So here our aim is to find the best parameters for theta, where we go for finding the minimization of the cost function. That cost function is nothing but the function which is dependent on the two parameters theta naught and theta 1 defined by function of j, which is consisting of theta 0 and theta 1 as parameters, which is nothing but the difference of the hypothesized value, that is h theta naught, h theta x and the actual value square. So if I go for looking at the multivariable parameters for this price decision based on different independent variables like size of the house, number of bedrooms, floors, and age of the home, we will have different prices, and our hypothesis function also will vary, where hypothesis function earlier it was only theta naught and theta 1 x. Now it will be changing to plus theta 1 x1 plus theta 2 x2 plus so on up to theta and xn based on the number of independent variables that are present. So I can represent this theta by this equation by theta transpose into x, where x consists of the vector belonging to all input independent variables, and theta consisting of a vector consisting of all parameters like thetas. That is to be put in the form that is theta transposed multiplied by the vector, which is a vertical vector, helping us to give the hypothesis function h theta x, that is for prediction. Now here cost function is nothing but for multivariable, it has to be calculated with minor modification in our earlier equation, where we go for taking the variables, sum of the variables, and then average it. Sum of the difference of the variable between the predicted and the actual, and take the mean. Okay. Then the concept of terminology gradient descent comes in order to go for minimizing the cost function, that is j theta naught theta 1. So for this, we need to use two terms. One is gradient, another one is the descent. So what this tells is that how well our hypothesis function is going to fit the data. In order to do that, we have to take the derivative of the cost function, that is j theta naught theta 1, and this is going to give me a slope at certain point, and this slope at the certain point is nothing but the derivative of that point. Now it is going to give, when I take this and vary that point, then it is going to give me a direction for the cost function fit. And this cost function is made to take steps down in the direction with respect to the steepest descent. For example, if you look at the third in the figure that is shown here, you can say the initial parameter consisting of weights. Now parameter is called as now in terms of weights. It is taking certain value initially, and then incremental value is given. Then its cost function moves to the next level in the downward direction. Again, it is given a new step. Again, its cost function varies, and error value comes down, and also cost function comes down. So we will be stopping the cost function optimization when the cost function value reaches the minimum value, that is at the bottommost layer of the error, cost versus weight or cost function. Now in this, we have to decide the size of the step that is to be taken through the parameter called as learning rate. That means I have to add one more term to this theta, that is obtained with the help of addition of alpha multiplied by the gradient, that is j by j theta of dou by dou theta of the cost function j theta, which is to be subtracted from the actual value, and that gives me the step to be adapted for the next cost function evaluation. Now if I take alpha value more, then what is going to happen? In that case, the cost function may decrease very slowly during iterations. If it is too small, the convergence is also going to be slow. So if you look at alpha large value, the cost function may go under oscillations. That means it may not reach the minimum cost function value at all. That is shown in this figure with the help of red lines. It is cost function value that is computed for every step. Each step is oscillating. That means it is unable to reach the minimum value. That means you are not able to optimize it. Then let us look slightly about model fit, where we will be having three terminologies. One is underfitting, overfitting, and appropriate fitting. In underfitting, what we see is that it is simple, but it is explaining actually the variance. But in this, what is happening? Some of the data which are represented by X. They are falling into the other category, which are represented by circles. So there may not be a good accuracy that is obtained with the help of underfitting. Likewise, if you see the overfitting, what you see is that it is too good to be said that it is true. Okay, but it takes a lot of time and you may not achieve such kind of fitting. But appropriate fitting may help us to get good accuracy, where in the error may be very, very minimal. And another terminology we need to have, that is regularization function, which is based on lambda, and it is given by lambda m by theta j. So this regularization function for a single independent variable and having only one bias term and one parameter can be represented like this, where you will be doing the iterations, where if I have multi-variables, I need to have the addition of regularization as an additional term that is shown here along with theta j minus alpha with the cost function that is being calculated with the help of this. And this term, it helps for performing the regularization. This regularization helps us to overcome overfitting and improves the performance of the model. The next one is decision tree in the machine learning algorithm, where we look for the concept like this. We have the data being based on the features to make the prediction, where we go for looking at the root node and the decision nodes, and under each decision node we have leaf node that are present. Now how it can be converted into the actual real-time problem, let us look at that by taking a understanding of the risk to prevent the heart attack. So you can have the age as a input factor and decide different age groups, like age group less than 18, age group between 18 and 30, and greater than 30. So you can now go for having one decision node based on all these three. One decision node less than 18 and another decision node having low risk between 18 and 30. Having greater than 30, there is another decision node. Maybe it is consisting of the people with smokers. Then underweight, you can also go for again checking whether the age is greater than 60 or less than 60. And based on that, you can go for deciding the risk. And usually under the age of 18 to 30, earlier it was low risk, but nowadays it is again seen there, some of the cases. But in smokers, usually if the non-smoker is there, low risk and yes. Likewise, you can have leaf nodes and the decision nodes division. Now let us look with respect to our salary and age. Now let us say that there are people with, we want to make a node having the person with age less than 30 as a root node, and the persons having age less than 30, there is only one person. So a person having age 22 and 23K salary is given a leaf node value. And second one with the two persons data with 41 age and 80,000 and 58 age and 1,50,000. So under this, what we can go for doing is we can use this decision tree for predicting the salary of a person with age greater than 50, where we can go place this person age with having a value of 50 under the category that is the second leaf node. So you can go for finding the prediction using the second leaf node corresponding to 2 by going to taking the average of the salaries under this leaf node, that is 81 plus 150 divided by 2, which gives the prediction for my person having age greater than 50. So this is nothing but the data splitting concept, which is based on some yes or no. So based on this basic concept, there are many other algorithms have been developed, but the problem is that there is a overfitting problem where whenever there is small change in the data. And if you see to the risk is involved due to overfitting, but it is very simple. The next model is random forest, where in random forest, we go for looking at the features, but they are separated into leaf node and left node and right node. But under decision tree, we have seen this. But under random forest, what it does is it goes for taking features 2 and 3 instead of 1 and 4, and it clubs in left node. And it goes for taking features 1 and 3, and it classifies them as left and right node. Okay. So let us look for how we can overcome this overfitting problem by taking a set of data consisting of 1,000 and having 10 trees, where in random forest we have number of trees like T1, T2, T3, so on. But these trees are being formed with records taking from subset of this 100 data, 1,000 data, like 100 records, 3 columns forming T1 and T2, and likewise others. Now we go for looking at prediction being done by tree 1 and tree 2, so on up to tree 500th. If there are 500 trees, then we go for taking the average of all these predictions in order to predict the salary of a person having greater than 50. Okay, that means since each tree is using different data, they go for taking the different pattern of the data, and they learn from different flavors of the data. So because of which we call it as ensemble learning. And also there is parallel learning happening in random forest. And this is used both in classification and regression. So how you can use in classification is that it goes for taking the inputs from the sub leaf nodes, and it goes for adapting what is known as voting. In that, it looks for the majority of voting, and the one which gets the majority voting, that will be gaining its classification under that the right category. For example, here apple has gained higher voting because of the apple being obtained in 2 leaf nodes, and then final class allotted to it is apple only. Now this random forest adopts the learning as well as regularization, because of which it is overcoming the overfitting and goes for giving the balanced fitting model. The next one is ADA boost, where we can see here decision tree and ADA boost. Models are present. 1, 2, 3 are models in parallel decision tree, and 3, 4, 5 are the models that are used in ADA boost. So what is the difference between ADA boost and decision tree? If you look at, in case of ADA boost, you can go for looking at the learners which have learned. But each learner may be weak learner or a strong learner, no problem. But the outcome of each learner is taken. It is going to be learned by the next model, and that becomes a stronger model. So ADA boost is helping us in reducing the error that is happening because of sequential learning by every model with respect to the previous model. Now, in this case, we'll take again back our salary and age as an example. It is going to adopt in this ADA boost the initial weight where it is equally taking the weights, and then the boost, it is going to boost the way of learning by forming what are known as stumps. Stumps, first one is the stump, that is M1, which is a model which is learning first based on the base model learning. So base model, how it learns, let us look at this. Now, let us take back our age and salary, and salary prediction has been done in the next block, and residual has been calculated by taking the difference between predicted salary and the actual salary. And then the base model is predicted, and then based on the base model and the assigned weights to the base model residuals, the second model in the form of M2 is going to learn and then again produce residuals. So you can see that the residual third one is highest, residual first one is lowest. Highest, the residual with higher value is assigned a higher weight, and a residual with lower value is assigned a lower weight. And based on this, the model M2 learns because it is having a base model input, and then it goes for giving us the result. So this kind of learning happens for all other terms which are present, and they are all at one level only. So let us look at the ADA boost further, where we have done the base prediction based on the average salary, which is all 36K, and residual being calculated, that is for the first line of 10 age, it is 16K. Now let us assume that prediction has been carried out, it is 10K. Now this is the base model M1, which is predicted, which has predicted 10K, and then it goes to minimize this residual by giving its learning to the second model, that is M2 model, and then the process continues like that. Now it is boosting the learning sequentially. So it is giving us further that all models do not have equal votes in the decision. And this concept was been used in Kaggle computation, which had won the prize. Then in ADA boost, again, overfitting is overcome, but it is slower compared to the others, which were discussed earlier. So ADA boost has got a grade XG boost. XG boost is the excellent predictive power model, and it gives very accurate results, and it is 10 times faster, and it adopts linear learning as well as T-learning algorithms. And it has got the predictive model, which goes for combining multiple individual models in an iterative manner, and it adopts an optimization algorithm like gradient descent optimization and avoids the overfitting, and it is supported by various types of languages. So you can see Python and C++, we know it, but others, they are being practiced by our IT engineers. Okay. Now, what are the boosting features for this XG boost? If you see, regularization is important, where it goes for avoiding overfitting using two kinds of regularization. One is L1 regularization, another one is L2 regularization, where L1 regularization adds penalty equal to absolute value of the weights. In the L2 regularization, which is used in deep learning, it goes for adding the penalty equal to the loss function proportional to the square of the model's weights. Now, secondly, it has got the ability to fill the missing values. This is the table without missing values. This is with missing values. Now, it has gone for predicting some missing values which are being filled automatically. And the third feature it has got is that the cross validation by splitting the data into batches and then training and stopping when there is no improvement. And also it helps for finding the optimal number of iterations, and it works parallelly. And also it adopts the concept of the pruning, which is keeping only those trees which are useful. That is shown here in the pruned tree, that is by cross. These are not useful sub trees. And last one is versatility. It is learning in a very good way, not having lot of oscillations in learning process, just wasting time and also not actually optimizing. So you can see the first one is optimized way of learning. Second one is having oscillation. I want the first one. Likewise, if you see the another kind of versatility, the model is achieving the cost function curve, which is appropriate in the first one and not the second one. So all these are possible which are incorporated in the XG boost. That's why this boosting algorithms are used. Then classification algorithms are logistic, support vector machine, and others. So for logistic, let us look at the linear regression. In linear regression, we cannot have the data to be fitted within two minimum and maximum. For example, it can be 0 and 1. So based on this, we can go for looking at another kind of fit that is called as logistic regression, where we can see that logistic regression is having a sigmod type decision-making function, which converts all the X values to fit within the predicted normalized values between 0 and 1, just avoiding the values which are going beyond the prediction between 0 and 1. So the sigmoid function is of the form 1 upon 1 plus e raised to minus x. For example, here I want to classify male and female based on the height and the weight. Now, if I have the prediction that is being done for a 110 centimeter height person as 0.8, in that case, as 0.8 falls on the upper side near to predicted value of 1, so it may be chance that 110 centimeter height person may be in the category of a male. And then logistic regression is clarified with the help of our earlier example, where I want to find out what will happen whether the person with age 31 years and salary of 34K is going to leave the company or not the company. Okay, the first one is column employee age and salary, and the third one tells that it is whether the person is living or not living in terms of binary value 0 and 1. Okay, then x is having a larger value more than 1, and it can extend between minus infinity to plus infinity. So in logistic regression, x and y values, as I just showed, and we need to find out the probabilities between which will lie between 0 and 1. Then go for adding the odds, which can have the value between 0 and infinity. Then take log of that, which might go to minus infinity to plus infinity. Then this value, if you are finding it out with the help of probability, is nothing but log of p divided by 1 minus p, where it fits into a function like b0 plus b1 x1, which is nothing but logistic equation. Now, logistic equation, if you take the inverse of it, it gives a sigmoid function. So the sigmoid function in our case can be converted from 1 upon 1 plus e raised to x being replaced by beta naught plus beta 1 x1, where it is now nothing but the sigmoid function inverse, which is nothing but logistic equation. So this x can extend by adopting the age and also the salary, that is having b0 plus b1x in which is dependent on age, and the other one dependent on salary. So when I adopt such kind of function, my all values will fit within the range 0 and 1 in logistic regression. Okay, it is simple, but the disadvantages are that it may not give correct values of prediction at all the times. So we'll go to the next one, that is k nearest neighbors, where if I have this age and salary again, then first one is plotted in the region near to the origin. The second and third are plotted with blue, and the third person with 31 age and salary at 34K is plotted with black. Okay, so what is the salary of this person? In order to assume that, what we do, we go for looking at the black one. He is nearer to the two blue ones, and we go for looking at the min and mode of these two neighbors. Here min is 0 and the mode value is 1 for both. So the prediction assigns logic 1 to a person having 50 age and 61K. Sorry, I told that it was 31 and 34K, but the example tells that it is 50 and 61K. So it goes for putting it in the category where it is a bit for the second category in the higher range, with a higher salary as well as more age. So KNN, it is called as non-parametric model because it doesn't need a model. That means it doesn't require any mathematical computation, but it goes for usage of number of clusters that is based on K. So this also is helpful in finding regression and as well as classification problems. Now, choosing the right value of K is an art. So you can see the decision boundary being obtained with the help of different K values. The K value with 5 is optimal, you can say appropriate fitting. The others are not that much. Then it is, here you can go for adapting cross validation also by again having the batch size split in the different datas and then train. Okay. Then support vector machine, it goes for deciding the decision boundary. And the decision boundaries are not as simple as a linear line. Based on the complexity of the problem, it becomes very difficult to have a single line decision boundary, and it becomes a complex line decision boundary. For example, in order to fit a complex data, we go for having the decision boundary with margin, and this margin, it is going to judge the outliers, as well as it is going to help it is not sensitive to noise, but it is also overcoming the outliers. So in this slide, what we can see is that there are two data from the two classes which are present on the margin, edge of the margin, that is decided for the boundary. And these will help us, if you know them, it will help us to classify the data very easily based on these support vectors that are present on the margin of this edge of the margin. There can be a case where the data is having the lesser size than that of the features, where we go for using hyperplanes as a boundaries instead of simple boundaries like a straight line or a boundary with margin. So in unsupervised learning, the last one is K means clustering. We don't have target column for classification in clustering. So classes are unknown. They are classified into two different classes based on learning process of clustering. Okay. So in case of clusters for our age and salary, we can make the clusters and decide appropriately by deciding appropriately the values of K. But in this case, what we can do is we can go for finding one distance measure, which is maybe based on Euclidean or Manhattan. For example, in this case, the two employers E1 and E2, the distance between them can be calculated using distance measure like 21 minus 40, that is the age difference square and salary difference square, and obtain the square root of that. Then this value that is found out, if it is less than the distance between E2 and E3, then we can say that E1 and E2 are close together. That means they are in one cluster. That is what is the meaning. So this kind of concept can be adopted for further data, and then clusters can be formed accordingly. Choosing a number of K is art, and it is also skill. You need to have some domain knowledge. Last one is a DB scan, where it goes for using hyperplanes which are arbitrary in shape. Now, implementation of motor fault prediction. For that, I have gone for you can go for using Colab platform, or you can go for finding the faults, and also you can go for comparison. So under this Colab platform, Colab is a having a cloud-based Jupyter notebook consisting of coding in the Python, and it doesn't require any software in the local machine. That is one important aspect. Then it can be suited for the data analysis and also for machine learning and deep learning. But it provides us an interactive environment. Not only that, it has got pre-installed libraries like Python, TensorFlow, and NumPy and Pandas, and plotting libraries. And importantly, it has got some high-speed processors, which are virtual machines like GPUs and TPUs. So this is a very good platform, which is freely available. You can try on this. So you can also collaborate this notebook with Google in Google Drive, and also you can import it to GitHub. Now, I will go for slightly explaining TensorFlow is used for machine learning algorithms, and Keras is used for deep learning networks. In TensorFlow, we have to go for importing this TensorFlow using some instructions like import, and you can go for importing other libraries using import instructions. Likewise, you can go for using other models which can be obtained from scikit-learn, and you can obtain the models like linear regression, decision tree, and then random forest. And also you need LSTM, for which we need to go for looking at high model library that is provided by Keras. Now this is a prediction being done by taking the induction motor faults that was shown in the form of data obtained from Zenado. Now I'll be showing the actual execution of this by using my code that is done on Colab platform in Python using Jupyter Notebook. Now, in the first part, what I would like to say is that I have to go for putting my Jupyter Notebook in Colab after developing. So, link everything to your drive by mounting it. So that is what is done here. So I am executing the first instruction and it is asking me to connect to my Google Drive. So now you have to choose your account and go for continuing it. And another continue, if you say, it goes for connecting to the Google Drive of your account. Then also on the left hand side, you can see some folders. Now you will be seeing that after mounting of this Google Drive, there is an addition of one more folder, that is Drive. Are you able to see? Anybody can tell me the endorsement? Give me the endorsement.
Yes, madam. Yes, yes.
And in my Drive, I have got my Colab networks notebook, sorry. So I'll open that Colab network. In this Colab network, I have said that in my data, I have got frequency data and then time data. Is it correct? So in frequency data, I'm going to select where there are 4 different data corresponding to healthy and damaged 1 rotor, damaged 2 rotor, and rotor bar ring fault. So, and one final, I need to go for pre-processing this and I have to put it in one single file. So I have gone for doing it in MATLAB, and then I have gone for producing one final processed data, and also have gone for adding the labels through program only. So you can see while adding the data, I also saw that I made a normalization of the data, and then I went for adopting the labels. So you can you see the Excel sheet? Hello? Hello? Can you see the Excel sheet?
Yes, ma'am. Yes, ma'am.
The values 1, 2, 3 are given to the data. Can you see that?
Yes, ma'am.
They are labels. So this is final processed file. So in order to use this file for a prediction, I need to incorporate some libraries. That is being done in the second step. Using NumPy, Pandas for handling the data and doing certain calculations and for plotting. Okay. Then I am going to read all the files and from the current directory and assign it to the CSV directory. What is the CSV? It is an Excel file extension, isn't it? Okay, now it is completed. Third one, you see that here it has read all the file successfully. Then we go for looking at the CSV file and printing some information from this file, where you can go for looking at the data normalized, which was earlier unnormalized, and also added with labels. So you can see, for example, 0, 1, 2, 3, only 5 rows are being displayed here in this case. There is a possibility that you can also display the entire data set through some kind of instructions like a loaded df, where this directory, this file has got all the values right from 0 to 1199. That means 10,200 datas are there, having different labels, 4 labels in all, including one healthy. Then I am going for linear regression model, where I am calling from sklearn the linear model, which is called using import linear regression. Okay, I have run that. Then I am going to split the data into train and test with input and output. So X train, X test, Y train and Y test. And then I'm going to fit the regression model by running this. Then you can see here the predicted one, which is plotted. The blue ones are nothing but the original, but the line that is fitted is this. That means there is a lot of, can you tell me what is the outcome of this linear regression? Can anybody tell me? This is having a lot of deviation with respect to the line that is fit for all the kinds of data, isn't it? That's why more error prone. So let us look at the performance with the help of the performance metrics like mean absolute error, mean square error, and root mean square error that is being calculated. And then let us go for fitting this using regressor.fit for the data corresponding to the test. Okay. Then prediction has been done. What is the Y value? These are nothing but classes that is varying from 0 to 3, but it has selected only the test labels. Then it does some manipulation on the X and Y values to fit within max and minimum, and then go for preparing a grid with an increment of 0.01 in between two values. Then it goes for plotting. Now you can see that these are the predicted values and blue ones are the, so you can see in blue color, they are predicted values, and red color, they are nothing but the test values. So if you want to look at the performance in terms of MAE, MSE, you can see that all are 0. It means that it is overfitting. Error is 0 means it is giving a very good result, but it is overfitting. It can't happen like that. Now let us go for using random forest. Again, we'll call the library corresponding to random forest using from sklearn.ensemble import random forest regressor. Okay, that is one. Then let us go for using column at index 0, that is corresponding to value, and assigning it to X parameter, X variable you can call, and labels to Y parameter using this execution of this block just now I have done. Then let us go for fitting the model by defining the number of estimators and the number of states and one score which is called as out of bag score. So we have used here regressor fit with the X train and Y train values. But let us go for finding the performance. So if you see here, performance is giving us out of bag score, root mean square error, mean square error, and another R square error. The next one is LSTM implementation. In LSTM, we are calling it with a keros. Okay, so you can see the last one. From keros.layers, import LSTM and some of the other features like bidirectional dropout, concatenate, simple RNN, and convolution neural network. Okay, so as I said, it consists of a convolution neural network. Along with that, it has got LSTM added. So you have to call all of them. Then first load that library, then go for assign a variable value and read it. Okay. It has given an error. Now now you can use the AI intelligence in order to rectify this error. So you can ask the Gemini to explain this error. Okay, so I'm doing that. You can take the help of this. Value is not actually defined. Data set is not defined. Okay, that means earlier I have defined with a different variable. That's why it is giving the error like this. That means I should have done it df dot values. Then it will give the correct reading of the value and applying it to the variable, assigning it to the variable value. Okay. So I have shown you the usage of Gemini for this. Okay. Then go for filling the data if they are missing. Then go for one important concept for this learning, which is supervised learning. Convert the series to supervised learning, which prepares the data for machine learning models with the help of this set of instruction that is been present here. Then go for converting non-numerical values, if at all they are present, to numerical values. In my data, it is not there, but still you can do it. Then read the values. They are again nothing but the categorical values, which are 0, 1, 2, and 3 that you can see here. Then go for another block where we go for actually reading the values in X and Y variables and split that into X train and X trace, Y train and Y test, and then go for training, reshaping the values using X train equal to X train dot reshape. Okay. And similarly, the other one. Let us look at the values that are present in that DF head with the help with the actual normalized values and the labels that are present. Then we'll go for defining two different folders, two different files named as x underscore test1 xcsv and y underscore test1 dot csv in the folder where we are doing the programming. And these are nothing but the two CSV files, which we'll be using later for LSTM. Then I have run both of them and my files are present in xtest x.csv and ytest y.csv. So where they are present? They are present in, we'll see that later. Then go for running the model, which consists of simultaneously you can see model equal to sequential and you have got number of add model.add instructions where you are taking the first LSTM with the AT return sequence true input shape x train dot shape value and you have addition of concept of dropping some of the neurons where you have used dropout dot with a value of 0.2% of the total neurons are dropped here. Again, LSTM with 40 layers is defined. And next again dropout with 0.3. Next LSTM layer with 20 neurons is defined. And again the last dropout is 0.2. Then last one is a dense layer that is added with activation ReLU. Then we have gone for using the compilation for the mean square error using optimization algorithm called as Adam optimization. Then metrics that are to be computed are nothing but MSE, MAE, accuracy, etc. So you can see here it is running and it has gone for the last. Now, though I had given, it has stopped at 112 iterations, where it has gone for finding the accuracy loss and for training as well as for validation. Okay. Then last one, we can go for saving this model in a file called as imfault new.h5. But for that, I am defining a folder called VJ under my drive, and then I am saving that model. Okay. And this model can be called either in your same program, or you can go for calling it in the deployed processor. So model summary has been read here after reading that model. And then computation of this model performance is being carried out. So you can see here the computation of model calculation has happened in terms of loss, accuracy, and finally the fitting. So this is how it runs and then gives me the values. And I have shown that summary of this in terms of the table and comparison. So you can see here the linear regression has given MAC of 1.17, decision tree 0. This is not a good fit at all. This is overfitting. Whereas random forest has given me MAC of 1.71, whereas LSTM has given me MAC of 0.0901, whereas accuracy corresponding to this is 0.62. That means 62%. So MAC is very low for LSTM. So you can say that it is the best model out of the all 4 models tested. So this is how I can go for predicting the faults in induction motor using the data that is taken from the Genodo site. Similarly, I have done for the energy prediction for using the same kind of models approximately. So linear regression, decision tree regressor, and then decision tree and LSTM. Again, you can see that LSTM has got MAC, which is least, whereas decision tree regressor and linear regression have got higher values of MAC. So this is the benchmark for performance comparison. So at this point, I'll be ending my session with the hands-on in Python. The same thing also can be done in MATLAB. So when in MATLAB, you can go for using the already defined and present apps for machine learning models, where you will be activating classification learner. Then go for opening a new session, take the data from a new file. So from where you will be taking this, it may take a little bit time for me now. So induction motor data is there. pre-processing has been carried out. In that, I go for process data. So in that frequency, in that I'll go for normalized FFT data, and then final process data file I'll select. It is loading that file in the classification learner, and it has loaded it. You can see on the left-hand side. Now you can see the various labels along with their normalized values. Are you able to see?
Yes, ma'am.
Okay.
Yes, ma'am.
Import this for
Hello,
learning.
ma'am, I'm audible.
Yes, sir, audible. Then go for adding. You can see here data set variable and label, and value is the predict. You need to predict for values. Then you go for adding all this, and then go for setting aside data set of 10% for testing. Maybe you can go for 20%, no problem.
Yes.
And then you can go for starting the session. So by default, it has chosen the first one, that is Findry. Okay. So I can go for training this using the train option. Then it has classified in a matrix called as confusion matrix, consisting of 4 by 4. Now, first fault, second fault, the normal, first fault, second fault, and third fault categories, they have been put in this. But out of also there are numbers which are put in the other matrix slots. That means some of them are classified as not of that class if they are taken from that class. That means there is accuracy problem. So you can also go for looking at what is the you can see the confusion matrix. I'll show it later. Region of convergence curve is there. Scatter plot of the data. If you see, all are falling on the same. So the data set is not that good. That's what we can see. Then I can go for choosing decision tree, find tree was used. You can see here decision trees. Out of that, find tree was used. Okay. Now let me go for using from other, like a logistic regression, and let us go for efficient regression. Okay. And go for training it. What is the error classification it shows? If you see, it is 30% accurate, whereas the earlier one was 31.4. Now we can go for choosing the next one from support vector machine. You have different kinds of support vector machines taking the say we can go for support vector machine and train it, and it goes for now training. It's taking little more time because we have chosen 31.47. So last, you can also go for choosing the neural networks. Let us go for choosing a medium neural network and go for training. It automatically selects some of the parameters like a number of fully connected layers, first layer size, activation function, and then it goes for a limit for the iterations, which is set as 1000 in this case. Then PCA, that is principal component analysis, is not being done in this. So it takes certain amount of time. You can also see the comparison with the help of result table. Whichever is been calculated, it is showing here. Okay. Apart from, I have only trained it. I can go for testing by using the testing option. It takes a little more time. Now it has come. You can see its results are a little better. 31.6 it is giving. The fault with one rotor bar fault, it is getting a better result. So you can go for testing and ask it to test for all by taking the test data that is split. Okay. Then it is showing the confusion matrix for model 4, which is performance matrix. And the accuracies are somewhere around 32.7, 33.2, 30.3, 31.7. So neural network earlier it had given 31 point something, 6. Now it is 32.7 for the test data. So you can now go for back and look for the table again, which will also have the validation results along with the tested. So you can see it here, accuracy for model testing as well as for validation. All are coming in the form of table, which helps us to compare them easily. But we don't have direct LSTM in this, so I cannot show you the same data being trained by the model, the LSTM model. So this is what is the implementation of the algorithms, which are machine learning algorithms, along with one deep learning algorithm for obtaining the prediction of the induction motor faults. So this way we can go for using it for prediction of energy also. That's what I have shown in the form of results, but it can be done by taking the data from the data ports which are available at different websites, and they can be studied for their performance using different models. So coming to the end of this session, what I would say that we have gone through the fundamental concepts of the machine learning models and deep learning models. And secondly, we have seen what kind of data are available for different kinds of applications like motor faults from different sites. And third point is that we have gone for looking at what are the platforms that can be used. And in the platforms, we have seen that we can use Colab platform, MATLAB platform, and also we can go for using the last one, that is we can also go for using one more platform if time is already over. If another slot is given for at least half an hour, I can show two things. Another platform that is which is AI development platform itself, called as Edge Impulse, which has the model development tool, which can be deployed in processors like Raspberry Pi directly by interfacing Raspberry Pi to the platform through Raspberry Pi model platform using VNC viewer. Okay, so this is what I have prepared and I have presented to you. I hope this is very helpful for you to understand the fundamentals and use it for applications, learning, and also for transferring this knowledge to your students in the form of projects. And also, if you are doing any
Yes, ma'am,
PhD,
yes.
you can use it for your research works as basic learning methods for verification of various models, and go ahead with the higher models and also modifying the higher models in order to do certain inventions. So for that, you require, for doing certain innovative model, you require the actual model working and how it works, where you need to do the model change in order to produce the new model so that it becomes your contribution. So this is, with this note, I would like to end for this today's session. And over to Madam and Sir.
Thank you, ma'am. Thank you. Any question from participant?
What
Ma'am,
happened?
Any question
your
from
session was
participant?
your
Hello?
session was very useful, ma'am.
Thank you.
Ma'am, I have
Yeah,
some
this is
doubts.
informative session, ma'am.
Yeah, if we don't have the data sets for training, ma'am, what we can do actually?
You have to prepare your own data. That is one thing. I have shown you 4 different types of websites from where you can search for it, first of all.
Okay, ma'am.
Then if your problem is very unique, which is not supporting any kind of data, you need to look for how you can generate it synthetically.
Okay, ma'am. Okay, ma'am.
That is second step. And
Okay, ma'am.
if possible, you can take the data directly from the live machine. That is
Okay,
the
ma'am.
third and the best method. That is what you can follow.
Okay, ma'am. Okay. Actually, what are the minimum number of data we needed, ma'am, for a data set?
So as
If you
sir
have-
has told earlier, machine learning algorithms do not require much of the data. But if you want more optimization and better accuracy, you have to go for deep learning models. Deep learning models, they require lot of data. So you require more than 1 lakh, like that, minimum at least. But 10,000 you start it, increase it by with the help of a method called as augmentation, that is data expansion. That is by by using certain statistical tools if it is time series. Okay.
Okay,
Then
ma'am.
there are certain tools available for enhancing the data with the help of augmentation process. Okay.
Okay, ma'am. Okay,
Both
ma'am.
for 1D data as well as for 2D data. Then you can look for the platform called as RoboFlow, whether it
Okay.
is assisting the augmentation process for 1D data or no, that you see. But for definitely image data, it is helping. For example, if I have FFT images, that's what I showed earlier, which has
Yeah,
been
ma'am.
conducted in in one of the papers. Okay, you can
Okay.
do the collection of such kind of data and enhance it if needed to be learned by the deep learning models. Okay, this is what I
Okay,
would give
ma'am.
you as a suggestion.
Okay, ma'am. Okay. Actually, my
Okay.
area of research is harmonic minimization in multi-level inverters, ma'am.
Okay.
So that actually I'm using sheep PWM techniques. So in that solving the equations, I thought of using an ML, but data sets are not available. But for solving for equations, when you are creating also, it's only 15 number of data sets are coming. So only asked
Then you have to look for
with the
a
minimum
good
number of data sets.
statistical tool for this. That's what I would suggest. Now you can
Okay,
meet
ma'am. Okay.
mathematics sirs. I'll tell you what is the route for this. You meet the mathematics sirs who have done PhD. They'll
Okay,
be
ma'am.
knowing good statistical tools which can help you for the generation of synthetic data for time series. Okay.
Okay, ma'am.
And then you can, there are some freely available statistical tools which can help for augmentation. Okay.
Okay, ma'am. Okay,
And you
ma'am.
ask
Okay.
them, you will get the information. Okay.
Okay,
What's
ma'am.
your
Okay,
name,
ma'am. Thank
please?
you.
Okay.
Maithili, ma'am.
Okay. From which institute?
Ma'am, Kongi Engineering College.
Okay. Okay.
I'm
Kongu.
I'm-
Okay. Okay. Nice to meet you.
Thank you, ma'am. Thank you.
Thank you, madam. Thank you.
No,
Nandini, madam.
Can yes.
I
Can
would
we
like to
conclude?
convey my heartfelt thanks to the organizers once again, and a special thanks to HOD of Electrical Engineering Department of Textile and Engineering Institute, Dr. R.N. Patil, and also to the director, Dr. L.S. Adibute, madam, who has been inspiring stock for me for all the time throughout my service, as well as beyond my service. And I have shared whatever knowledge I gained after enhancement of my PhD through machine enhancement of other concepts in artificial neural networks after 2020. This is what is my sharing in terms of not only fundamentals, but also in terms of implementation, and also in terms of deployment. I would have done if the time was a little more. This is what, with this small note, I will just hand over the mic to the organizers. Thank you. Thank you once again.
Thank you, madam. Thank you.
Thank you,
We
ma'am.
express
Madam,
our
please.
sincere gratitude to our esteemed resource person, Dr. Jayashreee Madam, for delivering an exponentially informative and thought-provoking session. Thank you, Madam, and also thanks to all the participants for their enthusiastic participation and calm listening. Okay, thank you all, and good night.
Thank you. Thank you
Today's
once
session
again.
Thank you,
was
ma'am.
over. Okay, please give the session. No issue.